Hello everyone and welcome back to my YouTube channel. I hope you are doing well. So I'm going to start the second part of exercise 11.4. I hope you have seen the first part. Okay. So in that video I have already solved these problems. You can see it here. The fourth exercise, in that already I have explained these 5 questions and I was solving this problem. Okay, I had already solved these two problems, that is the questions on proof. Okay, prove that LHS equals to RHS. So we have already started these type of problems. Now moving to the next part. Okay, so here is the first question. So you can see the question on the screen. Also you can refer your textbook. The question says that it is again prove that. Okay, this type of question will be asked for 3 marks, so it's better that you practice them well. Okay, so here what have they given? Prove that tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus sec theta into cosec theta. Okay, so this is the LHS and here RHS. In RHS you have sec and cosec theta. Okay, whatever is given in the RHS, always try to write the expression given in the form of sine and cos. Remember that. I have said this in my previous video also. Here also I am stressing on that. Always try to change the ratios in the form of sine and cos. That will make your work easier. Okay. Now see, here also they have all given hint also. Write the expression in terms of sine and cos. So how are you going to do this? Yes, let us start. So I will be taking LHS first. Tan theta, can I write that as sine theta by cos theta? Yes, this is in the numerator. In denominator we have 1 minus cot theta, so this will be cos theta by sine theta. Okay, I hope you know this. Then plus you have cot theta, so that will be written as cos theta by sine theta divided by 1 minus tan theta is what? Yes, it is sine theta by cos theta. So this is the first step. Okay, now what you have to do? Yes, numerator you can keep it as it is. Okay, but in the denominator you have to take LCM. So what will be the LCM? Let me write the numerator as it is, sine theta by cos theta. Okay, whole divided by, if you do LCM, if you take LCM of this denominator, it will be sine theta. Okay, because here nothing is there means it is 1, so 1 into sine is sine, and on doing the simplification you get sine theta minus cos theta. This LCM will multiply with this 1 as well as this whole, so you'll get this. I hope you know this step. Now this remains same, cos by sine whole divided by, again take the LCM here, so LCM is cos theta, and here cos into 1 is cos theta minus this is sine theta. So this is what you have got here, right? Now see what I will do. I'll just bring this to numerator. So you know that a by b whole divided by c by d, it can be written as a by b into, yes, d by c. This will be interchange like d by c. So that's what I'm going to do here. So sine theta by cos theta into, this becomes here in the numerator, and this is sine theta minus cos theta. Okay, plus you have this term also. I will do the same with this, cos theta by sine theta into cos theta by, what is this? Yes, it is cos theta minus sine theta. I hope you have understood this step. Next is, see, we will multiply sine into sine is what? It is sine square theta divided by this. I will keep it as it is, cos theta into sine theta minus cos theta. Again this will becomes cos into cos, cos square theta, and here you can see that in the first term here it is given as sine theta minus cos theta, but here it is given as cos minus sine. It's not same, So to make sine as positive and cos as negative, can I multiply with minus? If I do that, what will this becomes? This plus will become minus, right? And this becomes sine theta as it is, and this is sine theta minus cos theta. What we have done, just to keep it as this one, okay, the second term, the one which is given here. Why I'm doing this? So that I can take it common. If both of them are same, like a minus b, here it is given in the form of b minus a. So to make it a minus b, I have to multiply this whole with minus. So this becomes now minus. Got it? Now see, can I take common now? Yes, I can. What is the common? Yes, it is 1 by sine theta minus cos theta, right? Here also it is given, in this expression also it is given, so I can take that common. So in numerator, sorry, the remaining part will be sine square theta, correct, divided by cos theta minus cos square theta divided by, what do we have here, sine theta. Got it? I hope you have understood. Now we'll do the LCM again on this. So this remains same, 1 by sine theta minus cos theta, and this will be, on taking LCM, this is cos theta into sine theta, right? So now sine and sine will multiply. Why? Because see, if I'm writing the sine square into cos theta, this whole thing will multiply with this LCM. What is that? Cos theta into sine theta. So cos will get cancelled. That's why I'm directly multiplying this. Sine square into sine is sine cube theta. Similarly, cos square by sine and sine will get cancelled. If I multiply this with LCM, sine will get cancelled with sine. Remaining will be cos square theta into cos theta. So that is cos cube theta. Okay, we'll get in this form. Now what we have to do? We have to use, yes, a cube minus b cube formula. What is that? Yes, it is a minus b into a square plus b square plus ab. You should remember this. Okay, so that we are going to apply here. Okay, so what will we get? We'll keep this as it is, 1 by sine theta minus cos theta. Okay, and here the numerator will be this, applying this formula will get sine theta minus cos theta into sine square theta plus cos square theta plus sine theta into what? Yes, into cos theta whole divided by cos theta into sine theta. Okay, this is what we have got. Now if you see, everything is getting multiplied here, right? This into this and this into this. So numerator and denominator will get cancelled here. This will cancel with this, correct? And if you see, what is sine square theta plus cos square theta? Yes, it is 1 as per identity. So I can write here as 1 plus sine theta into cos theta whole divided by cos theta into sine theta. Now again this is in the form of a plus b by c. So I can reduce it in the form of, I can write this in the form of a by c plus b by c, right? So here this becomes 1 by cos theta into sine theta plus sine theta into cos theta by cos theta into sine theta. I can also write this as sine theta into cos, both are same. So here sine will get cancelled, cos will get cancelled, we'll get 1 here. And now what is 1 by cos theta? It is sec theta. Similarly, what is 1 by sine theta? Yes, it is cosec theta plus 1. Is this not equal to RHS? Yes, it is. You can see it. 1 plus sec theta into cosec theta. So we've got 1 plus sec theta into cosec. Okay, so I hope you have understood this. If yes, kindly do like the video. Okay, press the like button. Okay, only then you have to watch the next question. If you are understanding, kindly do like it, and if you find it useful after watching the complete video, share it with your friends. Okay, those who are in class 10. Okay, so moving to the next question now. So question number 4. Okay, prove that 1 plus sec theta by sec theta equals to sine square theta by 1 minus cos square theta. And they have given hint, simplify LHS and RHS separately. So we'll do the same thing. I will take LHS first. LHS implies what? 1 plus sec A divided by sec A, right? So this is in the form of what? A plus B by C. Okay, so what I will do, I will write this as 1 by sec A plus sec A by sec A. Okay, so what is 1 by sec A? It is cos A, and this is 1. So this is our LHS. Now take RHS. We can't reduce this further, so I'll directly take RHS. They have given sine square theta, sorry, A, not theta, A, and here 1 minus cos A. Okay, so what can we do? Yes, we can write this sine square theta as 1 minus cos square theta, right? A is given in the place of theta, so I'm just getting confused, but you can write A itself. Okay, I'm repeating as theta, but this is A. 1 minus cos square theta. Why? Because we have cos square A plus sine square A as what? Yes, it is 1. So what will be 1 minus cos square A? It will be obviously sine square A. So at the place of sine square A, I have written 1 minus cos square A. And denominator, let me keep it as it is. Now, if you see this, can I write this as 1 square? Yes, it can be written because 1 square is 1. Now, what is A minus B square formula? It is A plus B into A minus B. So I will write that only. So this becomes 1 minus cos A into 1 plus cos A divided by 1 minus cos A. So if you see, this and this are same, so they will get cancelled and you will get 1 plus cos A. So if you compare this LHS, that is equation 1 and 2, we can say that LHS is equal to RHS, hence proved. Right, here you have got cos A plus 1, again cos A plus 1, right? So I hope you have understood this. Now moving to, okay, so moving to question number 5. They have given proof that cos A minus sin A plus 1 divided by cos A plus sin A minus 1 is equal to cosec A plus cot A. And we have to use the identity cosec square A is equal to 1 plus cot square A. So if you look at the question, they are already given in the term of cos and sine. Okay, and in numerator, in the RHS, you need cosec and cot. So what we are going to do to convert them into cot and cosec, we will divide the whole numerator and denominator by what? Sine. Yes, so this becomes cos A by sine A, okay, minus sine A by sine A plus 1, okay, and it is divided by, yes, same, cos A by sine A divided by sine A. Everything should divide by sine. Sine A plus sine A by sine A minus 1 by sine A. Okay, so what are we going to get here? Let me change the color. Yeah, so see, here we'll get, this will be cot A minus 1 plus cosec A divided by, again, cot A plus 1 minus, again, cosec A. Now we'll rationalize the denominator. Okay, we'll rationalize this denominator. So we have cot A plus 1 minus this, so we can multiply this like this. See here, just a minute. Yeah, so on multiplying this like this, cot A plus 1 into, what is this, cosec A, so it is minus, I'll write it as plus. Similarly, cot A plus 1 plus cosec A. So we have rationalized the denominator. So minus was converted to plus. Now what we will get, if you look at the numerator, this is in the form of A plus B, correct, into A minus B, right? Here, is it, am I right? Yes, see, this is like A Just a minute. Yes, if you see this here, cot A plus cosec A. Let me write it again. Cot A plus cosec A minus 1. Okay, this whole is multiplying with, again, if I separate them, cot A plus cosec A plus 1. Correct? Why? This is A and that is B. So it is in the form of A minus B into A plus B. Correct? Whole divided by, here you can see that this is already in the form of, yes, you are right. It is in the form of A minus B into A plus B. So I can write directly it as cot A plus 1 whole square, okay, minus B. What is B? It is cosec square A. Okay, now again this numerator will also change. So this becomes cot A, because it is in the form of A minus B into A plus B. At the place of A we have cot A plus cosec A. So this becomes A square cosec A whole square minus B square, that is 1 square, divided by, what is this? Yes, what is this? What is cot A plus 1 whole square? So we have the formula A square plus B square plus 2AB, right? So I'll write it here, A square plus B square plus 2AB, 2 into 1 into cot A, minus this is already cosec square A. Okay, so on solving this, see what we will get. Here we will get A square plus B square plus 2AB, that is cot square A plus cosec square A plus 2 into cot A into cosec A minus 1 divided by, what we are going to write here. Yes, see, if you see, what is cot square A plus 1? It is cosec square A, correct? So can I take that common? Yes, I can take cosec square A. I can write here cot square A plus 1 as plus cosec square A, right? And this is same, 2 cot A minus cosec square A. So this plus and minus will get cancelled because it is plus and this is minus. So we are left with only 2 cot A in denominator, correct? 2 cot A in denominator. And now in numerator, if you see, what do we have here? Yes, see, what is this cot square A? Sorry. Yes, see, cot square A, we need it as it is because we have to cancel this from denominator. But can I write this cosec square A minus 1 as, see, we have 1 plus cot square A, which is equal to cosec square A. Now if I transfer this to LHS, RHS, this becomes cosec square A minus 1, and in LHS it is cot square A, correct? So that I can write, instead of these two I can replace it with cot square A, and here it is as it is 2 cot A into cosec A. So now if you see, this is also 2, that is 2 cot square A, and here we have 2 cot A into cosec A. Denominator is 2 cot A. Now if you look at the numerator, we have 2 cot A common. So if I take that common, we will get cot A plus cosec A, and denominator we have 2 cot A. So on cancelling them, we will get cot A plus cosec A, which is equal to RHS. Okay, so I hope you have understood this. It's little lengthy but simple. Okay, you have to just practice and you will get it. Okay, so I hope you have understood this question. Now moving to question number 6. So question number 6 is here. What have they given? Prove that root of 1 plus sine A divided by 1 minus sine A is equal to sec A plus tan A. Okay, so let me write the LHS here. 1 plus sine A into 1 minus sine A. What we need to prove? Sec A plus tan A. So how are you going to do that? So they have not given any hint. So whenever you get something like this in the denominator, that is 1 by a minus b, so always do rationalization of denominator. 1 by b, a plus b into a minus b, 1 by a minus b into a plus b, multiply and divide. So that's what I'm going to do here. Multiply and divide by 1 plus sine a, okay, like this. Okay, so this will become what? Numerator will be 1 plus sine a into 1 plus sine a is 1 plus sine a whole square, and this is in the form of a square minus b square, which is 1 square minus sine square, correct? A plus b into a minus b. So what is this? This root will get cancelled if I separately write 1 by sine a whole square divided by root of, what is 1 minus sine square? It is cos square a as per identity. So this will get cancelled, we will get 1 plus sine a, right? Root and square get cancelled. Here again root square get cancelled, so you will get just cos a. So on solving this, what is 1 by cos a and sine a by cos a? Yes, it is sec a plus tan a, and that is equal to RHS. Understood? I hope you have understood this question. Moving to question number 7. If you are liking it, kindly don't forget to share. Okay, so moving to question number 7 now. So question number 7 is given here. What have they given? See, prove that sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So it's very simple. Sine theta minus LHS I am taking. Okay, 2 sine cube theta divided by 2 cos cube theta minus cos theta. So if you look at numerator, sine is common in both. Yes, so I will take sine common. So here we will get 1 minus 2 sine square theta. And in denominator, again, if I take cos theta common, I will get here as 2 cos square theta minus 1. Isn't it? So what will be sine by cos? It will be tan, correct? Tan theta. And what about 1 minus 2 square theta? So can I write this 1 as sine square theta plus cos square theta, correct, as per identity? And this is 2 sine square theta. Similarly, in the denominator, this will remain as it is, 2 cos square theta. But at the place of 1, I can again write sine square theta plus cos square theta. Okay, why I put a bracket here? Because here we have minus, correct? That's why we have to put bracket. Now tan theta into, see here, cos square theta will get here, and 2 minus 1 is what? It is minus sine square theta. Okay, 2 sine theta minus 1 is 1. So sine 2 is bigger, that's why I have written minus sine theta divided by, here if you see, if I remove this, what will this become? See, I will do in one step itself. If I am taking this bracket out, okay, so this becomes plus, and this is also minus. That is minus, see, 2 minus sine square theta, and minus into minus is what? Yes, it is plus cos square theta. Got it? I have written directly that. Okay, at the place 1 I will write minus sine square theta, and minus into plus is what? Yes, it is minus, not plus. Yes, minus sine square theta minus cos square theta. So what we will get here? Here we get cos square theta. 2 cos square theta minus cos square theta is just cos square theta, and here you have minus sine square theta. So write it as it is. Both numerator denominator are same, so they will get cancelled, and you will get just tan theta, which is equal to RHS. Isn't it? Yes, you can look at it here. So I hope it's easier, you have understood it. Now moving to question number 8. So look at question number 8. It is one of the frequently asked question. Okay, they have given, prove that sine a plus cosec a whole square plus cos a plus sec a whole square is equal to 7 plus tan square a plus cot square a. Okay, so I will write this as it is. LHS sin a plus cosec a whole square plus cos a plus sec a whole square. Okay, so if you look at in the LHS, we have cosec sine and cos sec, correct? So there is no need of changing these two sign. Why? Because in RHS we need tan and cot, so we'll keep this cosec as it is. Okay, because we have the formula 1 plus cot square a is cosec square a, so that we might use somewhere. So I'll just expand this a plus b whole square, so this becomes a square plus cosec b square plus 2 sin a into cosec a. Similarly, here I can write this as a plus b whole square cos square a plus sec square a plus 2 into cos a into sec a, right? So if you see this sine and this cos, both of them are in positive, so I can use identity sine square a plus cos square a is what? 1. So directly I can write 1 there. Now if you look at here, can I write this as cosec? Yes, we have only cosec, so I will write it as it is, cosec square a, and this and this I will write as it is, 2 sin a into cosec a plus sec a and plus 2 cos a into what is that? Sec a. Now if you see, what is this? Cosec a can be written as in the form of tan. Yes, it can be written as 1 plus tan square a, correct? It can be written as what? 1 plus tan square a. And what about this one? Sorry, this is cosec, so not tan, it is cot, correct? Yes, it is cot square a. Next, if you look at this sine and cos, they are reciprocal of one another, so can I write this as 1 by sine? If I write this sine a will get cancelled, we'll get just 2. Similarly here, cos and sec, they are reciprocal of one another, so cos will get cancelled, we'll get just 2. So 2 plus 2, and the last one is what is this? Sec a. Sorry, it was sec square a, correct? It was sec square a, not sec a, so I'll write that as sec square a. Now here if you say 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 2 is 6 plus what is this? Cot square a. Now again sec, what can I write this as? Yes, I can write this as 1 plus tan square a, correct? So now 1 plus 6 is how much? 7 plus the left is cot square a plus tan square a, which is equal to RHS. You can look at it, right? So here we have proved this. So even this was very simpler. I hope you have understood these two. Now moving to the question number 9. So question number 9 is here. What they have given? They have given that prove that cosec a minus sin a into sec a minus cos a is equal to 1 by tan a plus cot a, and they have also asked to solve it separately, LHS and RHS. So let me solve LHS first. Oh, what is given here? Yes, it is cosec a minus sin a into sec a minus cos a. Okay, so I will keep sin and cos as it is, and I will change the other one. So this I can write 1 minus sin a minus sin a, here 1 by cos a minus cos a. So on taking LCM, this becomes sin a, and you will get 1 minus sin square a, correct? Because LCM will multiply with that. Here again cos a, and this is 1 minus cos square a. What is 1 minus sin square a? It is cos square a divided by sin a into what is 1 minus cos square a? It is sin square a divided by cos a. So if you see, numerator and denominator are similar. Okay, here you have cos into cos, here you have just cos, so one cos will get cancelled. Similarly, one sine will get cancelled. So numerator you get cos a into sine a. Got it? So this is first one. Now taking RHS. What is RHS? They have given it as 1 by tan a plus cot a. So can I write this tan as sin a by cos a? Yes. And what about cot a? Yes, it is cos a by sin a. Now taking LCM, we'll get cos a into sin a. And this will be sin into sin, like this, because LCM will get cancelled. Cos will get cancelled with cos of LCM. So this becomes sin a, and here cos by sin is what? Again cos into cos. So this is cos square a. Okay. Now what is this? This is in the form of 1 by sin square plus cos is 1, and this is cos a into sin a. When this comes to the numerators, this becomes cos a into sin a. This is 2. Now if you look at 1 and 2, we can say LHS is equal to RHS, because equation 1 is equal to equation 2. Just look at that. Okay, I hope you have understood this. And if you have if you are getting confusion over here, how we got sine square, see, whenever you have something like this, you have to multiply this whole with LCM. See, if I multiply sin a by cos a into LCM, what is that? Cos a into sin a. Similarly, the next term is cos a by sin a into LCM, which is cos a into sin a. Correct? So cos will get cancelled. You get sin into sin. That's why I have written here sin square. Similarly, sin will get cancelled. So we'll write cos into cos, that is cos square a. Okay, I hope it's clear. Moving to question number 10. Yes, the last question. It is given here. You can look it. So they have given, prove that this is equal to this and that is equal to tan square a. Means you have to solve them separately. So let me take this as first one, this as second, and this is third. So 1 should be equal to 2, should be equal to 3. So I will be taking equation 1. So what is 1 plus tan square a and 1 plus cot square a? Yes, it is sec square a as per the identity, and this is cosec square a. So in the form of sine and cos, this can be written as 1 by cos square a, and this can be written as 1 by sine square a. So when this comes to numerator, this becomes sine square a by cos square a, which is equal to tan square a. So this is proved. Now this is equal to 3. So 1 and 3 are proved. Now coming to 2, this one. So I will write this like this: 1 by 1 minus tan a divided by 1 minus cot a whole square. Correct? So what can we do here? Yes, again separate them. Write this as 1 by 1 minus sine a by cos a. Again 1 minus cos a by sine a whole square. So this becomes what? If you take LCM, this is cos a. Here this will be cos a minus sine a, and denominator again sine a. Here you will get sine a minus cos a, and this is whole square. Now what we are going to do? Yes, see. So we'll write it like this. See, this will become what? If I bring everything to the numerator, cos a minus sine a divided by cos a into, what is this? Yes, this is sine a into sine a minus cos a, and this is whole square. Understood? So it will be square of this into square of this. So what will be that? If I do it, see, this will become cos a minus sine a whole square into sine square a divided by again cos square a into this is sine a, sorry, this is minus not plus, minus cos a whole square. Okay, now use the formula a minus b square. So this is a square plus b square minus 2ab, correct, into what is that, this whole into sine square a. Similarly here cos square a into this is again sine square a plus cos square a plus 2, sorry, it is minus not plus, minus 2 cos a into sine a, correct. So these two are equal to 1, right? Sine square a plus cos is 1 minus 2 cos a into sine a whole multiplied with sine square a by sine square a, that's all. And here it is cos square a into, if you see again this is 1, so 1 minus 2 cos a into sine a. Now these two are same, so they will get cancelled. You'll get sine square a in the numerator and cos square a in the denominator, which is equal to tan square a. Now that is again equal to third one. So since 1 is equal to 2 and that is equal to 3, we can say they are equal to one another. Okay, so I hope you have understood all the problems which I have explained. If yes, kindly do like the video and also share it with your friends, and don't forget to subscribe the channel. Okay, also you can comment if you have any doubt, or if you have any other thing to say, like if you want me to make video on some particular topic, you can write that in the comment section. Okay, so we'll see you all in the next video. I hope you like this. Till then, take care, bye, have a great time.